right, this is your review for Unit 5, activities 28 through 30. So first couple of problems from activity 28 were where we learned the parent rational function, which is f of x equals 1 over x, and then the transformations of that rational function. So those took the form, remember, 1 over, or a over actually, x minus h plus k. And we had written down, just like with all our other transformations, what a, h, and k all do. So look back at the little cheat sheet that I had passed out to you that has this in there, or in your notes, to kind of help you remember. But remember, a is your vertical stretch. Remember that if it's in the denominator, it's a shrink. H represents your horizontal shift. If it's a plus, it's left. If it's a minus, it's right. K represents your vertical shift. If it's negative, it's down. If it's positive, it's up. Also, the last thing, if A is negative, if there's a negative in front, that means there's a reflection over the axis, which in this case means that your branches, because your original parent looks like this, with branches in quadrants 1 and quadrant 3. So if you end up with a reflection, remember that means it's going to flip them so that they're in quadrants 2 and 4. So that's kind of your overview for activity 28. Just going to look at a couple of the problems that relate to that. If you look at number 11, it asked if you had the point 8 1/8 on the parent graph, which you would. This is the parent equation. If you plug in 8, you do get 1 over 8. It asks where the image of that point would be on h of x equals 1 over 3x. So this all goes back to knowing your transformations and understanding what they mean. If you look at this h of x equation, that has a 3 multiplied in the denominator, which means that that is a vertical shrink by a factor of 1/3. Now, when we graph vertical stretches and shrinks, remember that we multiply whatever the y-coordinate is by the factor. So all you have to do here is, because you should know that this represents a vertical shrink, is take the vertical movement of the original and multiply it by the factor of the shrink. So 1 over 8 times 1 over 3 gives you 1 over 24. The x-coordinate stays the same, because when you have a vertical shrink or stretch, you're not changing the horizontal movement, which is the x-coordinate. So that is how I came up with that answer on your answer sheet. All right, I do want to do one graph for you. We're going to look at number 14. So number 14, the function was g of x equals -2 over x plus 5. So it had asked you to write down a whole bunch of different information. Excuse me. I'm going to write down the transformations first, because that'll be helpful when we go to graph it. So this negative means that I've got a reflection over the x-axis. The 2 part means that I have a vertical stretch by a factor of 2. And this plus 5 means that I have a vertical shift up 5. Now again, you didn't have to write this out. I am writing this out as a part of my work. It didn't ask for it in this particular case. What it did ask is for you to list the x and y intercepts as well as the asymptotes before you graphed it. So X-intercept, in order to find an X-intercept, you plug in 0 for y and solve. So if I do that, 0 equals -2 over x plus 5, and I'm solving for x, so subtract 5. Remember that when your x is in the denominator, you can kind of do a little switcheroo with what's on the left side. So that means I've got x equals -2 over -5, which would be 2/5. So that's how I got an x-intercept at 2/5. 0 is its ordered pair. To find a y-intercept, I plug in 0 for x. So y equals -2 over 0 plus 5. We're not allowed to divide by 0. That's a big no-no. That makes it undefined. So that is why we say there is no y-intercept in this case, because I am unable mathematically to simplify this when I'm trying to solve. So those are my intercepts. It also asks for my asymptotes. My asymptotes, I'm going to be able to see here when I go to graph. You can also get them from simply looking at the equation. In this case, I have a vertical shift up 5. I do not have a horizontal shift. So that means when I'm going to graph my asymptotes, my vertical asymptote is still right here on the y-axis because it hasn't shifted. You don't have to draw that. I'm drawing that for your convenience so you can see things a little more clearly. It does here have a vertical shift up 5, so that means that my horizontal asymptote is going to be right here at y equals 5. So when I was listing the asymptotes, the vertical asymptote is on my y-axis, so that's x equals 0 for that asymptote. This line is y equals 5. So these are the parts you had to have listed. Again, this that I wrote up here is work. That's going to help me to come up with my graph now. So I know that there's a reflection in the x-axis, so that means that my branches are going to be in quadrant 2 and quadrant 4. I probably should have made this a little lower because I didn't leave myself a bunch of space there, but that's okay. So my branches are going to be in quadrant 2 and 4. I've already done my vertical shift up 5 because I've got my new asymptote, and I also have a vertical stretch by a factor of 2. Remember that on vertical stretches, I typically look at what my parent pattern was. So usually from my origin, I would go right 1/2 up 2. Now, because I have a vertical stretch by a factor of 2, that means I'm multiplying, just like we did here in number 11 with the shrink. I'm multiplying all of these by 2. So right 1/2. Normally it would be up 4, but since it's a reflection in the x-axis, it's going to go down. So right 1/2 down 4. So I should probably finish my scale here. All right, right 1/2, again from my new origin, and down 4. 1, 2, 3, 4. So right here. Then right 1 would normally be up, but now I'm going to go down 2. So right 1, down 2, and then right 2, down 1. Now, also over here, I can plot my x-intercept. It crosses the x-axis at 2/5, so it's a little less than 1/2, so very, very close right about here. And I can draw this branch now. Please remember not to let it cross your asymptotes. So there's that branch. My other branch, instead of going right and down, I'm going to go left and up. So left 1/2 of a unit and up 4. I didn't really leave myself enough space for that one, but that'd be somewhere up here. Left 1 up 2. That one I do have enough space for, thankfully. And then left 2 up 1. So that is how I came up with the graph you saw on the answer sheet. All right. The next section, activity 29, is where we talked about factoring, simplifying, adding, subtracting, multiplying, dividing rational expressions, as well as talking about the restrictions. So again, can't do every problem that's on here. Certainly if you need extra help, you can, get that before, after school, or in the math lab. But I'm just going to look at a couple of these here. So first thing I'm going to look at is number 2. So number 2 on the activity 29, which is the 461 and 462. First one, it's just to simplify. So there is no multiplication or division, just simplifying. First step is always to factor. So this top is a difference of squares. 4 minus x times 4 plus x. On the bottom, when I factor that, I should see that there's a GCF of 4. So pull the GCF out. I've got 4 times x plus 4. Please remember to FOIL back out and check. It doesn't take very long. 4 times x is 4x. 4 times 4 is 16. You can do the same thing here. 4 times 4 is 16. Minus x squared. Inners and outers cancel. So I know I've done that right. Now I need to identify restrictions for my answer. I usually do this after I factor. If you want to wait till the end, that's fine, as long as you remember to check every denominator, not just the final answer. So here, I'm not allowed to have an x value that's going to make my denominator 0. So here, with x plus 4 is not allowed to equal 0. If I were to solve that for x, I'd get x not equal to negative 4. So that's going to be my restriction. Now I'm going to go ahead and simplify. X plus 4 and 4 plus x are the exact same thing, so those cancel each other out. And I'm left with 4 minus x over 4. Now, very, very important here, common mistake. Do not attempt to cancel these 4s. You are only allowed to cancel items that are separated by multiplication. This 4 in the numerator is attached to the x by subtraction. You cannot just hack it off. It needs to stay there. So this is your final answer then in number 2. Next one that I would like to take a look at is number 5, where you have division. So original problem on number 5, I've got 4x plus 4 over x squared divided by x squared minus 1 over x squared minus x. So, looking at that, again, first step, because this is division, is to take the reciprocal of my second fraction and change that division to multiplication. So, change division to multiplication, flip the second fraction. Now I'm good to go. So now, next step is to do the same thing that I did in number 2. First, I need to factor. So this numerator, GCF of 4, it's 4 times x plus 1. Denominator is a monomial, meaning it only has one term, so that does not factor any further. Numerator on the right side fraction, I can take out a GCF of x, so x times x minus 1. That doesn't factor any further. Denominator, that's our good old difference of squares, x plus 1 times x minus 1. So because this is now written as multiplication, I can just take all the factors and write them kind of in a string. So out in front on the numerators I have 4x, then I have an x plus 1, and I have an x minus 1. In the denominator I have the x squared, should go in front, and then I've got x plus 1, and I've got x minus 1. Now, identifying restrictions. Again, if you like to wait till the end, I'm okay with that. However, you have to remember at the end not to look at the final answer. Look at the step where everything is still there before you cancel and it's factored. So my restrictions here, I know that x cannot be 0 because that would make this part 0. So, can't have 0. This means that I can't have either positive or negative 1. I search through all my denominators. I don't see anything. Remember that because this was division, I also have to check my original denominator, which is the new numerator. This is a 0, this is a 1, so I've already covered those. So I've covered anything that would ever make the denominator 0 with my restriction. So now I'm going to go ahead and cancel. X plus 1's go away. X minus 1's go away. Here, this is different than what I had in 2, which is the reason why I wanted to do these two problems to compare them. Here, the 4 and the x are separated by multiplication. So it's okay, because I have an x down here, to cancel. So I can cancel this x with one of the x's that was here, so the squared goes away. So I only have 4 left in my numerator. I have only an x in my denominator. Again, don't forget to record your restriction as part of your answer. All right, next, moving on, we had the addition and subtraction and complex fractions. So I'm going to look at number 8, where it asks you to simplify, and that is a subtraction problem. So original is 2 over x plus 3 minus x over x minus 1. So in order to add and subtract, first thing I do is factor. Well, they gave you a nice easy one here. Nothing else I can do to factor that. Those are already in simplest form. So next I find my LCD. LCD has to be factors that they share, which are none in this case, as well as factors that appear that they don't share. So in this case, x plus 3 and x minus 1. So that's my LCD. That's step 2. I've identified my LCD. Also, I can, if you want, go ahead and identify my restrictions here. X can't be negative 3 and x can't be 1. Again, if you want to wait till the end, that's fine, as long as you remember to check all your work. So now I have to do fraction conversion. So my LCD was x plus 3 times x minus 1. So all I'm doing, remember, in this step is I am rewriting these original fractions with the new common denominator. So my original left side fraction had x plus 3 in the denominator. It did not have the x minus 1. So that means I multiplied this denominator times x minus 1. Whatever I do to the denominator, I must also do to the numerator. So I'll write times x minus 1 there. Second fraction, the original had the x minus 1, but it didn't have the x plus 3, which means I now have to multiply the numerator by x plus 3 as well. All right, I know that I'm going to need to distribute here. 2 times x is 2x, 2 times negative 1 is negative 2. Up here, x times x is x squared, x times 3 is 3x. When you add and subtract fractions, remember that the denominator stays the same. So copy my LCD down for my answer here. Now the numerators I can go ahead and subtract. Keyword, subtract. Remember that that means you have to distribute the negative. So it's 2x minus 2 minus x squared minus 3x. That negative gets distributed to both. All right, so now combine any like terms. I've got negative x squared. I've got a negative 3x and a positive 2x, which gives me a negative x. And then I've got a negative 2. So if you want to factor out the negative, you could. So I have some people write that as negative times x squared plus x plus 2. You don't have to do that because this doesn't factor, so there's nothing else you're going to be able to simplify. But I did want to point out that if you did that, that's okay. It would not be marked wrong. And don't forget to list your restrictions. Again, we said x couldn't be negative 3 and x couldn't be 1. So there is your answer for 8. Next, Number 9 was a complex fraction. It was a relatively easy complex fraction, but you had 5 over x plus 6 divided by 10x over x squared plus 3x minus 18. So this is a relatively easy complex fraction because there is no addition or subtraction in the numerators or denominators. So each one only has one fraction, which means I'm going to go ahead and rewrite this. This is 5 over x plus 6 divided by 10x over x squared plus 3x minus 18. This is now essentially the same thing as I had in 5. So change the division to multiplication. Identify restrictions. I know from this one that x can't be negative 6. Remember, when it's division, I have to look at numerator and denominator here. Probably should factor that first, huh? The top one, that factors into x plus 6 times x minus 3. So this was my original denominator. It's in the numerator now, but originally it was the denominator. So I have to include this in the restrictions too. So essentially you have to look at the whole second fraction. So negative 6 I've already got covered. This one means that x can't be 3. And this denominator means that x can't be 0. Again, if you can't just see those, then set each of those factors equal to 0 and solve. So now it's multiplication. I can go ahead and write it as a string, 5 times x plus 6 times x minus 3 on top, 10x times x plus 6 on the bottom, and then do my reducing. X plus 6's cancel. The 5 and the 10 can reduce to make this guy a 2. So I'm left with x minus 3 over 2x. Again, x not equal to negative 6, 3, or 0. All right, now we'll look briefly at the next section where you are analyzing graphs. Remember that these types of graphs, you may be asked to identify asymptotes or holes on a non-calculator part, but the actual graph itself you will not have to do without a graphing calculator. So I'm going to look at number 16 next because it covers all the little pieces that were in the questions before. So number 16 asked you to analyze and graph. Remember, when it's asking you to analyze, it's asking you to find your intercepts, your asymptotes, your holes, all of those good things. So the original function on 16 is f of x equals x squared minus 6. Oops, not minus 6, minus 36. I misspoke. Over x squared minus 5x minus 6. So, in order to find x and y intercepts, remember I plug in 0 for the opposite variable. Now, it does not matter whether you want to look at the factored version here or whether you want to look at the unfactored version. There are some pieces of what we have to do where one is an advantage or where the other is an advantage. But if I'm trying to find the y-intercept here, that means I'm plugging in 0 for y, or for x rather, to find the y-intercept. So if I plug in 0 for x, it's probably easier to do that in the originals rather than the factored. So 0 minus 36 is negative 36 over 0 minus 0 minus 6. So I get negative 36 over negative 6. So that means my y-intercept is at 0, 6. To find my x-intercept, I plug in 0 for y. So 0 equals x plus 6 over x minus 6, x minus 6, x plus 1. If I'm solving this for x, the first thing that I would do is multiply by the denominator on both sides. When I do that, the denominator cancels out. So I just end up with 0 equals x plus 6 times x minus 6, which gives me x equals plus and minus 6. Now, if you look at your original restrictions, x is not allowed to equal 6 or negative 1. So that means I have to toss out the positive 6 here, which means the only actual x-intercept is at negative 6. So negative 6, 0 is the only x-intercept that I listed. Again, we had to toss out the other one because it's one of our restrictions. It doesn't make sense. So next thing I want to do is identify asymptotes. Remember that when we are looking for vertical asymptotes, that's different than when we are looking for horizontal asymptotes. To look for the vertical asymptotes, if you need to look back at the section, remember this is 29.3, vertical asymptotes are values that make the simplified denominator equal to 0. So if I am simplifying this original expression, these x minus 6's cancel. And so I've got x plus 6 over x plus 1 for the simplified version of my f of x there. So values that make the simplified denominator equal to 0 is just negative 1. So that is my vertical asymptote at x equals negative 1. Horizontal asymptote you get from looking at the original and doing the ratio of the degrees depending on which one is bigger. So if you look at the degree of the numerator, the degree is 2. So degree 2 for numerator. The denominator is also degree 2. Now this is something you have to have memorized. It's in your book. You had to star it, highlight it, whatever when we went through the lesson. It's on page 454, right in the middle with big stars. You have to memorize what the degrees tell you about the horizontal asymptote. Here is the first bullet point. When the degrees are the same, the horizontal asymptote is the ratio of the leading coefficients. So the leading coefficient in the numerator is 1. The leading coefficient in the denominator is also 1. 1 over 1 is 1, so that means my horizontal asymptote is 1. So when the degrees are the same, you do the ratio. Remember, if the denominator degree is bigger, then you write y equals 0, or x-axis is your horizontal asymptote. When the degree is larger in the numerator, then you write none. There is no horizontal asymptote. So again, that all is on page 454. You have to have those memorized. Okay, I found x-intercepts, I found y-intercepts, I found vertical and horizontal asymptotes. The only thing left to find are the holes. And holes you find by finding what would make the original denominator 0 that is not a vertical asymptote. So basically, what canceled? So if I look at this, what canceled was x minus 6. So that means that 6 is where my hole is. So there's a hole at x equals 6 in my graph. So all of that you should be able to do without a calculator. Any of these types of questions could be on the non-calculator part. However, to do the actual graph, you will be allowed to use a graphing calculator if you would like, because sometimes the shapes get a little funky. Not always, this one isn't, but sometimes they do get a little funky. So here, when you're drawing your graph, now I just have to kind of put into play all the individual things that I just found. So I know that I've got a vertical asymptote at x equals negative 1, so I draw that in with a dashed line. I've got a horizontal asymptote at y equals 1, so I'll draw that in. I'm going to plot my x and y intercepts. So my y-intercept at 0, 6, right up here. My x-intercept at negative 6, 0, right here. I know I have a hole where x equals 6. Now again, if you don't know what the shape looks like, you can look at your graphing calculator to get the shape. So when I go through, I see that I have branches that look something like this. And the only thing I have to do is find where x is 6 and make sure that I draw a hole there in that branch. So there's that. And then on the other side, this branch should look like this. And so that is what your graph should look like on 16. All right, so last thing we're going to go over is from activity 30, excuse me, where we were solving the rational equations. I've got the hiccups now. Solving the rational equations and the work problems. So we're just going to go through just a few of those. So we are almost done. So first one that I want to look at is number 5 on page 471. You had x minus 3 over x minus 1 minus 2 over x plus 1 equals x minus 5 over x squared minus 1. So first thing I would do is factor so that I can find an LCD. So this guy, of course, becomes x plus 1 times x minus 1. And so now I'm going to convert so that all of the fractions have the common denominator. So this one, I had to multiply the bottom by x plus 1 to get the LCD, which means I need to do so on the top as well. So x plus 1 times my original numerator, which was x minus 3, minus, and then the second fraction had the x plus 1 but didn't have the x minus 1. So I'm going to need to multiply its original numerator by the x minus 1. The right side already had the common denominator, just wasn't in factored form. So I don't need to change its numerator at all because I didn't change its denominator at all. Okay, so now over here, I need to do some foiling and distributing. This is x squared minus 2x plus, or minus 3x plus x, which is minus 2x, minus 3. Over here, remember that this is subtraction. So the distribution by itself gives you 2x minus 2, but because it's subtraction, I need to change both the signs in order to make this addition so that I can just combine like terms. So that now is going to give me x squared minus, let's see, minus 2x, and then minus another 2x is minus 4x, and then negative 3 plus 2 is negative 1. So that's what I get when I do the subtraction changed to addition on the left side. Again, I don't need to do anything on the right side. That's already done. Now, since I have the same denominator on both sides, remember that that means you can multiply the entire equation by the denominator, which essentially makes these cancel. So now I'm just solving this quadratic equation right here. So I'm going to move this x over by subtracting. I'm going to move this 5 by adding. So now that gives me x squared minus 5x plus 4 equals 0. And I can solve that for x. So x minus 4 times x minus 1 when I factor it. So x equals 4 or x equals 1. Now remember, you have to go back, check for extraneous solutions. My original problem, x cannot equal positive or negative 1. So that means automatically I get to cross this guy out. X equals 1 is extraneous. The only solution left is 4. So if I check that, 4 minus 3 is 1 over 4 minus 1, which is 3. So 1/3 minus 2 over 4 plus 1 is 2/5. I'm checking to see, does that equal negative 1 over, this would be 16 minus 1, which is 15. So is that negative 1/15? Well, this guy is 5/15. This is 6/15. 5 minus 6 is negative 1, so it checks. X equals 4 is a good solution. All right, going to look quickly at number 6 as well. 1 over x minus 3 equals x over 9 minus 3x. Now, for all of these, even for number 5, you could have done that a completely different way than I did and still gotten the right answer. Because there's a lot of choice there. You can, after you combine the fractions, you could cross multiply if you wanted to. You could, at the very beginning, multiply the entire equation by the LCD and get rid of it. So there's a lot of choice in the steps, but you should get the same answer. This one, again, there's a lot of choice here. I could factor and try to find a GCF and do it that way, but since there's just one fraction on each side, I think that in this case the easiest way is to just go ahead and cross multiply. So when I do that, 1 times 9 minus 3x is 9 minus 3x. Over here, x times x minus 3 is x squared minus 3x. So again, this is quadratic, which means if I'm going to solve it, I want to move everything over to get it equal to 0. So these cancel too. So I've got x squared minus 9 equals 0, which means x equals plus or minus 3. Again, you have to check that. Look back at the original. Original restriction, x cannot equal 3 itself. That would make both the denominators 0. So that means our only valid solution, the only one I have listed, is x equals negative 3. Again, you can plug that back in. This one's easier to check than the other, but x equals negative 3 does indeed work. All right. Last one, number 7, where you had the work problem. It gave you the information and said that Raj took 5 hours to complete the job. Ebony took 4 hours, and Jed, who took 3 hours. So Raj, Ebony, and Jed are all working together, and it wants to know how long it would take them all working together to complete the job. So remember that we put everything in terms of what can be done in 1 single hour. So if it takes Raj 5 hours to do the whole job, that means 1/5 of the job can be completed by Raj in 1 hour. Ebony can complete 1/4 of the job in an hour, and Jed can complete 1/3 of the job in an hour. Again, we want to know how long it would take them all to do it together. That has to go on the bottom. You can't just put equals t, it's equals 1 over t. So, again, work problems, you end up with the variable in different places. Sometimes it's over here, sometimes it's over here. Since it's over here, I think the easiest way is to just go ahead and add 1/5 plus 1/4 plus 1/3. The common denominator there is 60, so multiply by 12, multiply by 15, multiply by 20 here to get that common denominator of 60. So 12 plus 15 plus 20 gives you a total of 47. So 47 over 60 equals 1 over t. A lot of you have gotten to the point where you know if that's 1 over t, that t is the reciprocal. If you haven't gotten to that point, that's okay. You can cross multiply here to get 47t equals 60 and then divide. So t equals 60 over 47. Now, this is a word problem, it's a work problem. We're asking how long it would take them. So in this case, decimals are appropriate for a final answer. Once you've solved for t here, you can put 60 divided by 47 in and see that you get approximately 1.3 hours when all 3 of our friends work together to complete the job. All right, so that reviews activities 28 through 30. Please remember that for the unit test, it also covers activities 25 and 26. So if you need a refresher on that, you can go back and watch the activity 25 and 26 review video. Happy studying!